Hello, in this Excel tutorial for Chem 1B, we'll be looking at the second part of the data workup from Experiment 5, namely calculating a pKa value from our data now that we've plotted the graph. I've gone ahead and I've plotted my graph with each of the four sets of spectral data, and the first step is to decide on a wavelength to use for the subsequent calculations. Your lab manual suggests using a wavelength that shows the largest difference between the basic and the acidic pH, and just visually it's going to be over on this side of the graph, and I have two data points with very similar values for the difference between these two. The pink line down here is the same at both of these values of 0.0357. The blue line, there's a slight increase at this 600 nanometer wavelength, so I'm going to go ahead and use 600 nanometers for my absorbance values. I'm going to go ahead down to the bottom now, and I'm going to, below my graph, and I'm going to enter a caption that this is my calculations, and maybe I'll put in 600 nanometers just to be clear where I'm doing them. I'm going to need to know the pH, the difference between the absorbance value and the minimum, so that's going to be between my buffered solution and this low absorbance value for the acidic form of bromethymol blue. And the other one was the maximum, so that's going to be that basic form, the blue line, minus the absorbance value of my buffer. I'll calculate the ratio of these quickly, and then the pKa. Starting with this pH, I don't have a cell with the pH in it, so I'll go ahead and type these in, but I'm going to want to do it for both of the buffered values, the pH 6.7 and the pH 7.1. So this is 6.7, and let's start there. For this cell, I'm going to hit equals so it knows I'm typing in a formula, and scroll up a little bit so I can find it. And I wanted to take my absorbance value for the 6.7 at 600 nanometers and subtract the minimum absorbance. Now the maximum absorbance is over here at 1.16. The minimum is this 0.0357. I'm going to go ahead and make this an absolute cell reference by hitting F4 to toggle those dollar signs up there. And that's because I'm going to drag it across to get my 7.1 measurement in just a minute. Equals again. This time at, again, 600 nanometers, the maximum value. I'm going to use an absolute cell reference, and then subtract the absorbance of my buffer. And I'm doing the absorbance of 6.7 right now, and again it needs to be at 600 nanometers. Enter. The ratio is relatively easy to calculate. Equals, so it knows that you're looking for a calculation. Click on the numerator, which is going to be that AB minus min. The slash key, which is right next to your right-hand shift button, is the dividing by for Excel, and then click on the denominator, that absorbance maximum minus absorbance buffer, and then enter. Goes ahead and calculates that for us. To do the pKa, you need to rearrange the buffer equation that appears in your lab book, that pH equals pKa plus log of base over acid. In this case, we're going to rearrange that to isolate for pKa, and what it's going to end up equaling, so I'll use equals, is it's going to be the pH minus the log of our ratio. And there's a function in Excel called log, so I type in the name of the function, open parentheses, and click on what I want it to take a log of, close parentheses, enter. And that calculates a pKa of 7.039. Now you'll notice my absorbance values for 6.7 are here in column E, and the absorbance values for pH 7.1 are 2 columns over. I can take this whole column of data, move right twice, delete this stuff in the middle. That was a transmittance for the pH of 7.1. Click it so it shifts the cells left, and I need to change this pH value to 7.10. and it will display my calculated pKa here. Now you need to know how to do all these calculations by hand for purposes of quizzes and exams and lecture, but we can keep going and do the average, and we could calculate a standard deviation for these two measurements. though the standard deviation on two measurements isn't worth much. The function for a mean or an average is the word average, open parentheses, click, hold down, and drag over the cells I want to average. And the standard deviation is STDEV, again, open parentheses, and drag over the cells you want to take the standard deviation of. And so in this case, I have very tight values for my two buffered solutions. You may have considerably more variation, but this comes out to an average of about 7.042. And that concludes this video.